Hi, this is the next video for Year 2 Pure. We're looking at exercise 7C and we're looking at the double angle formulae. Now we're given sine plus or minus a, sine of a plus or minus b is, well, you know what we're given because we've been looking at these. Now if I've got a and a, sine of 2a is sine a cos a plus cos a sine a. Well, that's just 2 sine a cos a. So I don't need to remember this because I can work it out every time. But this is a useful identity. And we can do the same thing with the other two that we're given. We're given cos and tan. I'm just going to pause them and fetch them up on my computer. So we're given cos a plus b equals cos a cos b minus sine a sine b. So of course if I've got a plus a, cos of 2a is cos a, that's cos squared a, minus sine a sine a. So that's another one. Now we can do more than that because remember sine squared plus cos squared is 1. That means I could write this differently. Cos of 2a is identical, and I should use the identity symbol, is identical to, instead of cos squared, I'm going to write 1 minus sine squared a. So that's 1 minus 2 sine squared a. Or if I replace the sine squared with 1 minus cos squared, I could also write it as 2 cos squared a minus 1. Again, don't need necessarily to commit them to memory, just know that we're given the double angle formula, and from that, sorry, we're given the compound angle formula, and from that comes the double angle formula. And likewise, we're given tan of a plus b is tan a plus tan b over 1 minus tan a tan b. And of course, if it's tan 2a, if I just replace my b with another a, well, tan a plus tan a, 2 tan a, over 1 minus tan squared a, and there is an identity for tan squared, but we'll not go there yet until later on in the chapter. So each of these, the double angle formulae, I need to know how to use, but I don't need to memorise them because they come from the addition formulae that I'm given. So if we look at example 7, write as a single trigonometric ratio, so cos squared 50 minus sine squared 50. Well, looking at my identities, cos squared minus sine squared, a is obviously then 50 degrees, which means cos 2a is 100 degrees. 2 tan pi over 6 over 1 minus tan squared pi over 6. Well, again, using the tan squared, clearly a is pi over 6, so 2a is pi over 3. Oops, there you go. Tan of pi over 3. Now, for sine 70 over sec 70 is a little less obvious just because we're not used to sec, but always with these things, Sec, cosec and cot, write it out as sine and cos because that's what we're used to and we see how it simplifies. So that's 4 sine 70 divided by 1 over cos 70, well, divide by a fraction, 4 sine 70 cos 70. Well, that's two lots of 2 sine 70 cos 70, and the reason I've written it like that is because I've got 2 sine A cos A. So A is 70 degrees, so 2A is 140 degrees, so 2 sine 140 degrees. I could go further than that, I guess, if I was asked to. There's my sine graph, and I can see that the sine of 140, well, that would be the same as 40, so I could write that, but I don't. It hasn't asked me to, so that would get full marks for this sort of question. Okay, example 8, parametric equations. X equals 3 sine theta, y equals 3 minus 4 cos 2 theta. Annoying because I've got theta and 2 theta. So what I'm going to do is I'm going to write cos 2 theta in terms of theta. You've got to be able to spot this. 2 theta and theta do not go together. So y is 3 minus 4 lots of, well, cos 2 theta, that's cos squared theta minus sine squared theta. And since I've got sine theta, I'm going to write cos squared as 3 minus 4, 1 minus sine squared theta minus sine squared theta. So I've got 3 minus 4, 1 minus 2 sine squared theta. Now x over 3 is sine theta, so then y is equal to 3 minus 4, 1 minus 2 x squared. So I've written y in terms of x. Yep. I'm hesitant because I'm looking at the book and it's not quite the same. I think they've just used they've just used a slightly different strategy to me. Okay, example 9. Given that cos x is 3/4 and that x is between 180 and 360, find the exact value of sine 2x. Well, sine 2x is 2 sine x cos x. So I need a value of sine x given that cos x is 3/4. Remember, sine squared x is 1 minus cos squared x. So that's 1 minus 9 over 16. So sine squared x is 7/16. Now I need to know if sine x is positive or negative. Let's have a look at a sine graph. Between 180 and 360, sine is negative, so sine x is minus root 7 over 4. I've had to take the negative square root because between 180 and 360, sine is negative. So sine 2x is 2 times minus root 7 over 4 times by 3 over 4. 2 over 16 is 1 over 8, so minus 3 root 7 over 8. And because it asks for exact values You can't just use a calculator. I don't think it would give you the surd. Also, of course, you can't use a calculator to decide the sine based on the value of x. Now I've got sine x, of course, it's easy to work out tan x, or tan 2x, well that's 2 tan x over 1 minus tan squared x. So tan x, well that's sine x over cos x, minus root 7 over 4 over 3 over 4, that's minus root 7 over 3. So I've got two lots of minus root 7 over 3 over 1 minus 7 over 9. Minus 3 root 7. Okay, have a go at 7C, and I'll see you next time.